I am so sorry, guys. I think I've been talking to myself. So sorry about that. I think I pressed mute by mistake. Sorry about that. So let me go back. I don't know how long I've been mute, so if you guys can tell me. But let me just go back. So just I went through the introduction about myself. My name is Akim Olu. If you guys missed that already, sorry about that. I think I mistakenly mute myself. Sorry. So I work for a company AkolagTech. I've been doing IT for more than 15 years in the tech industry, ICT. I had work experience with company, Goldman Sachs, IEEE, New York Times. I have expertise in Linux, DevOps, automation, software development. My free time, I teach Linux, cloud computing, coding, just to give back to the community. Also, and I dive into introduction to AWS. So AWS, everybody know what AWS does, but if you don't, it's just, it's the leader in the cloud computing industry. What I mean, the leader is before anybody else um, start thinking about cloud computing in a more e-commerce environment, or like in a very device environment where it's been adopted by a lot of company. Amazon is the one that just stepped in because they find a niche for themselves, and then they decided to make it available to other company as well. Most widely adopted cloud services for millions of customers, startup, small, medium, and big enterprise, even government agency. Amazon was launched in 2006, 13 years ago. I mean, 2006, which is about 13 years ago, or even before then. And Amazon was invented to satisfy Amazon e-commerce. Actually, if you look at the story of Amazon, it was invented to satisfy their own challenges that they face internally, which is they wanted to scale quickly and they wanted to scale on demand for computing resources, but there's a limitation in terms of how they can scale because of these um, people work in silos and people work, takes time to get the procurement of hardware infrastructures and get the system up and running, and then, make it, so that you can configure the network. So it does take time. So they decided to come up with a solution to solve these computing resources challenges, which is to automate the infrastructure, to make it more like a like on-demand services, like just like you buy stuff on your e-commerce on the e-commerce website. So they make it, you know um they solve their own challenges, and then they make it available to other companies. So initially, when AWS services, um before, the first offering of AWS services, and I was probably one of the one that adopt AWS at early stage when I was working for a company back then, is computing resource, which is EC2. This is one of their core services. It's probably two back then when they first started, and storage, S3, because a lot of people, they wanted to be able to store their videos and pictures and archive it in S3, which is managed by Amazon. I mean, AWS at that time, to save costs on storage, computing, and uh, also server. So, what is the benefit of AWS overall? So, the benefit of AWS is number one is on-demand computing resources. What I mean on-demand is ability to be able to spin up computing resources on demand. Like you don't have to wait. For example, if you want to spin up Amazon computing resources EC2, less than 5 minutes, you'll be up and running. You can log in to your server or whatever, and then you can start consuming and utilizing those resources. Scalability is another one. You can scale, based on your demand. If let's say you own an e-commerce website, or you own, when it's off season and when it's on season, when you get spike in your requests on your website, you can scale up to meet those demand, and then scale down when you don't need those resources. So only pay for what you use. That's the cool, model of cloud computing. You pay for what you use. So if you not using it, you're not paying for it. So which is what a lot of people love, because that's how you can measure your cost in the IT service delivery. So savings on computing resources and another one thing that you save huge amount of money on your computing, because you utilizing what you are using, and then you're not paying for uh, excess resources. And then especially for startup companies, this is also allow multiple startup companies to start on a low budget, because anyone can easily start a company without incurring a lot of expenses on infrastructure. So you just go to Amazon or any other cloud computing, and you can start building your software or running your your company on top of the cloud. So you don't have to wait. So, and the cost is always uh, is savings. You save a lot of money on the resources. All right. So AWS, like I said, in their initial stage, AWS start with one or two, three services, and now they have 165, and then it keep growing. You don't need to use all of them, but for most, they just have it available so that you can have a pool of resources or a pool of services that you can use to develop your product or services. So 165, services currently, and more. AWS benefit for business. So how do you benefit from AWS? And that's a lot of people talk about this, like, AWS is costly, AWS is, the reality is AWS can be the best solution for most businesses in terms of resources and savings. So number one is eliminate and reduce data center or infrastructure costs. So a lot of people are moving into the AWS because they see there's a need and there's an urgency to keep up with their competitors, to be able to meet their customers. So it reduces your data center, your infrastructure costs. So you're not spending a lot of capex on all these infrastructures. So where you offload all your data center, all your IT costs by adopting AWS, because you see most companies do save a lot of money in the beginning. And I can give you an example. For us as a company, we do save money for paying for only what we use in AWS. We eliminate, having a data center, um, uh, procurement of hardware, upgrading, patching, and also have to decommission those servers and have to pay for electricity, cooling. So you do save a lot of money. Automation. So automation, easy to launch computing resources, like I said, on demand. You can build your own automation through AWS, so that you can even customize all your resources, so that you can build your product, you can design your software, you can have if you adopt DevOps culture, you can be able to do so many things with AWS, because they make it so available for anyone to use, on demand, for anyone to use, at their own time. So infrastructure as a code. You can also make those infrastructure leveraging cloud formation, which is one of the presenters going to talk about cloud formation. So there's so many tools you can use. So it gives you all these resources. So, for businesses to adopt and for businesses to use for their own benefit, increase productivity. So one thing is you increase productivity, fast delivery of product to your customers, get your product and services quick to your consumer without wasting time. That's the whole goal. Be able to set up, test environment, build your development product, and then once you're ready, you can push it to your production environment and have it available to your customer. Scale up and scale down. Be able to scale, like I said, when there's a demand for your services or products, you scale up, and then when time comes when utilizing those resources, you scale down. But in a traditional data center or traditional IT infrastructure, you can't do that because you already expense out all your infrastructure. So you pay for those hardware, networking, and so even if you're not using it, they still idle, and you still, you're not saving money. But with AWS or cloud computing, you're actually saving money because when you are not in your busy season, you can scale down easily and you save money. All right, so this is just an example of how auto scaling web. Let's say you have a web application architecture in your business. This is just to give you an example of how can you design your infrastructure on AWS. So if you look, let's say you're e-commerce, you can have your infrastructure built up on AWS. So you have CloudFront distribution where your customer coming directly through CDN, and then it distributed to S3 buckets. So for example, let's say I give an example. You want your customers to be able to download some specific files, so you can put it in an S3 bucket, and then that can also do some automation where you can create a EBS snapshot. You can log in, and then you can get access to your to your uh, to your web servers, your web server. And if there's a spike within your e-commerce, so with auto scaling, you can be able to scale up on demand, and then to auto scaling, and then you can scale down as well when these resources when these resources are not being used. So this is just a typical AWS infrastructure. There's more you can do with this. This is just like one snapshot. I mean, one snap example of how do you configure your AWS. But there's a lot to it as well that you can do. So this presentation is going to be available for everyone to use. To go through and the recording. So we're going to share this with everyone as well. So that ends my presentation. I'm going to pass it over to another presenter to take over. So Sam, I'm going to pass this over to you.
Sure, thank you. Can you hear me? Hello, everybody. My name is Samuel Shobowale. Thank you very much, Akim, for. Currently, I'm a DevOps engineer working for Blink Corporation. Before that, I was working for AWS Premier Partner. What we did was help over 200 companies migrate to AWS, and we still, uh, basically we helped over 100 and over 200 companies migrate their applications to AWS. And when they get to AWS, we help them, operate successfully on AWS and continue to. mentioned, there's over 100 AWS services. Naturally, you probably would never have to use even more than 20, more than 30. Some people use just one AWS service throughout their time using AWS. The services are split into multiple categories. They have the compute, which is the EC2 that compute cloud. And there's also ECS and all of that. I would try to go briefly into the ones that here. It was kind of difficult because I had to pick a few for us to talk about. So it's quite difficult to select some, because there's just so many of them, and some of them are just so closely related. It's hard to tear it apart and just talk about one without talking about the other. But the ones I selected though are the most popular ones out there that people use. So once you encounter somebody using Amazon AWS service, there's a high chance they're using at least one of these services we're going to be talking about here. So the first one is Amazon Elastic Compute. Basically, AWS's way of giving you a server. Right? Of course, a lot of us are used to using VPS. This is Amazon's own.
Hey Sam, your audio is breaking. Can you make sure, like, I think it's breaking up. Your audio is breaking up a little bit. I think it's breaking up and then it'll come back.
Okay, is it better now?
It's still breaking. It's kind of low though. Maybe you need to. Do you have a mic?
No, the mic doesn't work.
Okay, it looks better now.
Oh, is that so?
Yeah.
Is it better now?
Yeah, it's better now. Much better.
I think I figured out the position. Okay, so I was saying Amazon Elastic Compute Cloud. Basically, this is Amazon's own way of offering us a virtual server. But what makes this special is how easily you can scale it, how easily you can, increase the number of servers you have hosting your application, how easily you can increase the size of the server. Say you have a server that has 5 gig of memory, you can easily up it to 10 gig of memory. You have to stop your application temporarily, but it's easier compared to what we would do in traditional environments where you have to maybe open your server and plug in some more memory modules, or if it's a virtual machine, it's you need a system administrator to go and figure out the downtime and all of those things. Now you can just use a button or command line trigger, whichever one you. Yes, they come in all kinds, all shapes, and sizes. They have the compute optimized ones, they have the storage optimized ones, they have the memory optimized ones, they have the network optimized ones. So they try to give you something that you can get, basically you can get a good price for. So if you want if your application requires a lot of storage, then you probably are better off using a storage optimized EC2 instance. I wouldn't go into details about the types of EC2 instance and all that, but there's a lot of them, and we can talk about them in details in maybe other presentations. And one of the biggest advantages of EC2 is the pricing model, and generally Amazon as well. They allow you to pay for what you use. Right? The instances are on-demand instances, so you only pay when you're using them, and you pay per hour. That's what most people use. There's also an opportunity to use spot instances, which is basically you can choose how much you are willing to pay for the instances. And if they basically use supply and demand to to offer you the instance at that price. And if the market determines that the price of the instance is more, they will shut down your instance. You understand? This is just Amazon's way of offering you a good deal, for the EC2 instances, especially because there's a lot of them, or they have a lot of capacity that people are not using. You can also reserve instances for, say, you tell them or you sign a contract that you're going to have instances that you will use for 4 years, for 2 years, and they'll give you a really good price, maybe half of what they give for on-demand instances. And that's, you know, a lot of companies take advantage of those different pricing models. I'll go on to the next one, which is Amazon auto-scaling. Without speaking about auto-scaling or talking about EC2 without talking about auto-scaling, it's kind of like just talking about half of the whole, you know, system. Auto-scaling is one of the things that makes Amazon EC2 the best and popular services. Why? Because it allows you to manage all your EC2 instances. So, like we talked about having servers. Most people don't have one server. Most people have 2 servers, 3 servers, because there's a lot of compute work that has to be done. Your application needs a lot of computing, it needs a lot of memory, you know, to handle the traffic, you know. So you use auto-scaling to manage this, right? But auto-scaling allows you to do this on various levels. So you can basically choose how many instances you want in an auto-scaling group. So if you have 3 instances, you can basically say, okay, I want to increase these 3 instances to 10 instances with just one click of a button. That's the great thing with auto-scaling. And AWS will bring 10 new instances for you, whichever size you want. Auto-scaling will also allow you to choose, say, you know, between this time of the day to that time of the day, I don't want to have any instances running. And it will shut down all your servers. And say you have like a school, for instance, and you people go to school between 9 to 5 in the, you know, or like 7 a.m. to like 4 p.m. After 6 o'clock, shut down all my servers, and auto-scaling will shut down all your servers. And in the morning, 6 o'clock, it will bring up all your servers. So you can see how if you were paying on demand per hour, you are saving over 2/3 of the cost that you will pay if you just did not shut down your server at all, right? Because you're only paying for like 8 hours out of the whole 24 hours in a day. So that's a really great advantage of auto-scaling. And you can also set auto-scaling to say, if I have the CPU utilization of my servers is reaching, say, like 75%, can you bring up new servers to handle the load, right? This is the high availability portion of auto-scaling. So it makes sure that your application is always available, because if your application is, you know, is being pegged by, you know, maybe new people, maybe you have a lot of new people coming to your website, you can say auto-scaling, please bring up new, you know, I need 10 more instances if my CPU utilization is getting to 75%, and so on. So yeah, auto-scaling helps us to low cost, to lower our costs. It offers us high availability and fault tolerance, right? Fault tolerance is basically when, so auto-scaling has health checks. So if you have 10 instances and you want to have 10 instances, if something happens to one of those instances and it dies, auto-scaling can easily replace that instance for you and make sure you always have 10 instances. You know, so this is the fault tolerance part. So if something happens, you will always have an instance to replace it and get you back up and running, like nothing happened. Your customers will not even know few servers. This is what big companies like Netflix, Amazon, Facebook use and ensure that they have high reliability and high availability. The next one is Amazon, excuse me, elastic load balancing. Well, also speaking about auto scaling, without speaking about elastic load balancing is not touching the whole picture. Load balancing is basically, a lot of us are probably familiar with what load balancing is. For those people that are not, load balancing is a solution that allows various back-end servers. So you have a solution in front of all your servers that is the single point. All your customers know that. Load balancing allows you to be able to route that traffic to all your back-end servers, whichever algorithm you want to use, just to make sure that no one server has all the, or no two servers have all the traffic and the other servers are not handling any load. So load balancing helps you route the traffic and distribute it fairly. Amazon offers its own load balancing service, which is Amazon Elastic Load Balancing, right? Because of course you would need to route traffic to your EC2 instances within an auto-scaling group, or even if you don't use an auto-scaling group, you need to route traffic to your EC2 instances. But it also does more. Apart from routing traffic, which is a typical thing a load balancer does, it can also help you offer your SSL encryption. Instead of placing your encryption keys and all that on your server, the load balancer can help you terminate and offload those SSL encryption connections. So now your servers do not actually have to do any computing when it comes to SSL decryption or encryption. Load balancer will handle that. And the good thing is Amazon has its own load balancing, Amazon has its own certificate managing service. So you don't have to go to GoDaddy to get your own certificate or even pay for it. They offer it for free. So you could easily connect that Amazon's certificate manager to Amazon's Elastic Load Balancer, and you would have a fully secure, highly reliable service. Right? Go on to the next one, which is Amazon. This is basically AWS's way of offering us a managed database. You know, it offers us compute, it offers us storage. It will be, wrong not to offer us database. So, managed database service where you can bring up any type of database you have. Well, not any. Most database offerings, most database engines are on Amazon, and they continue to bring up new ones all the time. They have MySQL, they have MS SQL, they have Postgres, SQL, they have Oracle, and they have Aurora, which is Amazon's own fork of MySQL, and they have so many other managed database. But the advantages of this is something that is not easy to manage. But Amazon has broken it down for us, and now we can easily manage our databases. And not just the management part, it is also highly available, right? They allow you to be able to say, okay, I want to have my data in my database across another availability zone. So I don't want it to just be in one place. I want it to be in two places at the same time. So say something happens, say there's an earthquake in one place, or maybe there's a power failure in one particular place. I want to make sure that people can still access my data, right? RDS offers you that. It offers you, and they promise like something around 99.95% availability or uptime for your database every month, which is very high, especially if you are familiar with just database failure in general. Something just happens and your database just breaks down. Lots of companies experience this, and you don't know why. So RDS is definitely a good bet for you to go if you're looking for something like that. It's highly available. The pricing is similar to EC2 instances, basically on demand and reserved. You can reserve for 4 years, for 2 years, however amount you sign the contract, and they give you a really cheap price compared to the regular on demand, right? The on demand, which basically means you pay for each hour you use. If you use it for 10 hours, you only pay for 10 hours. You shut it down, you don't pay, and you also pay a little bit more for a little bit as well on top for the storage of the data that you have. But yeah, that is it about RDS. S3 is Amazon's object storage service. Object storage is different from block storage that a lot of us might be familiar with, which is like hard disk drive or your memory card or all of this. These are regular block storage services, but object storage is a little bit different, right? It stores your data using objects. It stores your data as objects, right? And Amazon is offering, if a lot of us are familiar with Dropbox, then you'll be familiar with what S3 does. You can easily just store your files and your media, especially, which is what a lot of people use Amazon S3 for, just storing like the videos and media and pictures and all of these things. The way Amazon S3 is designed, Akim mentioned that S3 was one of the first services that Amazon offered, which is correct, because they offered Amazon EC2, Amazon S3 at that first time because they were trying to focus on just offering high availability and durability and all of this. So in the design, the design of S3 means that it has in itself inbuilt high availability. So every time you store anything on S3, they promise that there is 99.999 up to 11/9 of durability there. That means the chances of you losing whatever you store is so minimal. I mean, most of us have probably had issues where your hard drive just crashed and you lose all your data. You know, if you're lucky, you have backup, but some people are not that lucky. But Amazon S3 is promising us 11/9 durability. So the chances that you will lose any kind of data is near zero. But another great thing about Amazon S3 is you can just use it to host websites, to host static websites, right? You could just put your code on S3 and it can be hosted as a website. You probably have to point it to its own DNS endpoint or use a CloudFront distribution in front of it, but you can use it to host a website. And if you think about the regular ways of hosting websites, which you always need a server, and now there is the option to just use an S3 bucket to host your website, you will see how really interesting that is. I mentioned earlier, it is highly available. It's highly scalable. So whatever load, however the amount of load it is that are requesting for for access, they will always be able to handle the load and handle the traffic easily. Depending on the type of S3 that you choose to use, there are different classes of S3. The standard one, which is what everybody uses, and then most people use. And then they also have infrequent access. So if you think you're gonna not be using your S3 as much, we'll charge you less if you store it in an infrequent access place. It's going to be slower, but since you don't need it too many times, you just pay less money. Or if you want it to be archived, they have a particular service called the S3 Glacier, which is just for archive. And if you want to retrieve your object from archive, it takes maybe 2-3 hours for you to get your data, but that's just their deal, and you pay much less. Some of us are probably familiar with tape storage in the past. That's Amazon's own. I mean, they also have their tape storage, but that's their own way of kind of trying to help you to archive data, especially data that you do not access frequently. So that's it for S3. The final service I would like to talk about is Amazon's CloudFormation. So, with the whole advancement of cloud and everything, right, we can see how the progression has moved from just typical on-premises data centers to basically now we are at the level where we can write our entire infrastructure as code, right? Amazon's offering of that is CloudFormation. You can basically, all the services I just talked about, from the S3, from the Amazon Autoscaling, Elastic Load Balancing, and more, and all of the Amazon services, you can write them as code. And once you can write them as code, that means you can easily automate them. You can easily include them into your automation processes and so on and so forth. So you can basically bring up your entire environment just by a click of a button, because you already have it written as code. So this, that's AWS CloudFormation allows you to have easy deployment of AWS resources. You can basically carry your entire infrastructure from one region and put it in another region. Or maybe you are a cloud service provider, and what you're doing is you're creating environments for multiple customers. You can, somebody just comes and says, hey, I need an environment in AWS. And you can just say, take this code and you have your environment. That's one of the great advantages of CloudFormation. You can replicate for multiple environments, especially for people that have dev, QA, stage, prod environments. This is great because you can now have the exact same environment in your dev, in your stage, in your QA, in your prod. And you can also use version control to manage your infrastructure, right? This allows you to, when people make changes to the infrastructure, you can see, oh, this is where the changes are. For those of us that are familiar with GitHub, GitLab, or just Git in general, version control and all that, CloudFormation helps us to be able to do that with AWS resources. And the good thing about, or the excellent thing about CloudFormation is you pay nothing for it. You only pay for the resources that you have been able to bring up with CloudFormation. And that makes it, something that is worth talking about. I believe that is it for my presentation. I hope you guys got a good insight into these services. We obviously didn't talk about them in details, but hopefully we'll be able to. Sure.
Thank you, Sam. Thank you, Samuel.
No problem.
Appreciate it. Thank you. So our next presenter is Adeyemi. So Adeyemi, over to you. Please take it over.
Okay. Hello, everyone. Okay. I'm Adeyemi, right? From. Can you hear me?
Yes, I just missed Sam. I can hear you.
Okay, good.
Yeah.
Yeah. So I'll be talking briefly on how to adopt AWS in Nigeria. Currently, I work with Cobalt 360 as a tech lead. I manages the infrastructure, right? I will present my screen like I have just 2 slides here to show you guys. Okay, let me put it on the screen.
So we have the screen to share. I'm sharing it, so you can continue.
Oh, okay. Oh,
yeah,
okay. Good.
I already
Good.
start sharing it. Don't worry.
Okay.
Just keep talking.
Okay. Yeah. So good. So basically, I will just introduce what we do at Cobalt 360 to you guys. So at Cobalt 360, we are into transportation, right? That's aggregation of truck owners. So matching them with a shipper. Those are the people that want to get their goods moved and oversee the journey of that trip, right? So the good in transit are always high, in prices. So average goods moved around 8 million naira, 12 million naira. So of course, security of those goods are our concerns, right? And Cobalt 360 as a company, we're really a startup, and we are growing big. We are growing relatively fast. We are in a verge to build what we call a global logistics operating system. All right. Currently, we raised 30 million in Series A. That was 2 months ago. Yeah, currently we are in overseas Africa countries, Ghana, Kenya, Togo, Rwanda, Uganda. So we're still growing and we're still expanding. Yeah. So part of the thing that is actually keeping us moving is that we rely on AWS, right? Our journey, we started last year, 2017, officially. Then we were on DigitalOcean. The whole application was just a single application that is a monolithic application, just the way every startup starts, right? So then we find a need to scale. We run on a single instance on DigitalOcean. Then I remember vividly there was a situation whereby there was a crash. Then we went there for over 4 to 6 hours, which means we couldn't track goods in transit, which means we lose communication of what is actually going on. So it was a very bad experience for us because all point of communication was just done. So we started doing the manual stuff. Then we eventually bring it back, but we couldn't scale because we're not on AWS at that point in time. Yeah, DigitalOcean have some other things that we can actually leverage on, but I guess they were missing out the auto scaling part at that point in time, right? So then we decided, okay, yeah, we have to move into AWS. Prior to that time, we were recruited into YC. Then we were given AWS credits. We met the AWS team. Then they introduced us to AWS. So then we see the need to actually move to AWS. So moving to AWS, we decided to, okay, first of all, break down our applications from monolithic application to microservices. So that way we can leverage, we can utilize more of AWS resources. We move into a microservice. We've started using EC2 instance. Also, we started using S3 for our buckets bucket for all our images and files, right? So then all our DNS records was on DigitalOcean. Then we moved them back to Route 53, 55 here. So it was a good journey for us. Then we started seeing needs as regard to what AWS provide. The load balancers, the auto scaling group. So it was just a cool transition for us. I think we did that within 2 weeks after we've decoupled our applications, right? Then we started utilizing more of AWS resources like going the serverless way with S3. So today, all our applications, our web-facing applications are hosted on S3, then rendered by CloudFront, right? Okay. Then we build a CI/CD pipeline which automatically deploy from our build tools down to S3. Then also revalidate our CloudFront. So it was a cool transition. So basically today we work with that. We also work with we brought our data pipeline down to AWS. I think it's not my slide is missing. We leverage on QuickSight, we leverage on Athena. We currently work with SageMaker, and we're also looking at test tracks for machine learning and all. So AWS for us was just a savior because we were able to build up all our resources on AWS. We were able to interconnect, right? And then we were able to manage our scalability, right? Currently running in 6 countries is not a base, and we actually need to ensure that we are uptime at all times, right? So today is very easier for us with auto scaling. Then we also use CloudWatch to monitor what is going on with our resources. We also leverage on CloudTrail as well. So also backing up all we leverage on RDS. Backing up RDS is very easy. So I think for us it was just a good way. Then for me, I would say if you want to go the AWS way to adopt AWS, I think you have to start from your application. Then start looking at the minimum resources that you can use, which is your EC2, your S3, right? Then also bring it down your Route 53 down to it. Your DNS record down to Route 53. You have the certificate manager, which can help you to provision quick certificates, right? For your website, for your APIs, endpoints. Also, you have API gateway, which can be built, which can be layered in the front of all your microservices, right? And it also assists you when you want to auto scale, right? So it's my presentation is just a very quick one. If you have questions as regard to how we've gone so far, I'll be glad to answer you. Also today we also build our media service on S3. Like we were able to manipulate our images on the fly, scaling and all, and then everything just went through. So we've enjoyed AWS so far, and I think it's cool for everybody to actually move on. See what AWS provide for us today in Nigeria. Right. So thank you.
Thank you, Adeyemi. That's a very good
Yeah.
presentation. And this is just to give everybody overview of how, and you can see from a company perspective on how they use
Yeah.
AWS. So if you're thinking into adopting AWS, so this is a good scenario. Thank you very much. Appreciate it. So we're gonna move to the next presentation, which is Ewere Diagboya. Please take it over. Can you hear us? Ewere? I think he's probably having problem with his mic.
Hello.
Oh, good. All right, take it over. Ewere.
All right. Okay. Hello, people. Good afternoon. My name is Ewere. Um, yeah. Okay. So I'm I've been in software engineering for the past 15 years. Used a lot of technologies and languages across board, and I dived into DevOps and cloud computing about 4 or 5 years ago, and it's been an interesting journey. So today I'll be focusing on just DevOps and the DevOps culture and some principles around DevOps that applies across board, and then give us certain tools in AWS that help you to drive innovation using DevOps as a tool and improving delivery. All right. So DevOps demystified. So that's just some basic information about me. Yeah. All right. Let's go to the next slide. All right. So what is DevOps? Primarily this session is supposed to take roughly an hour, but I'm going to sharply run through it within the next few minutes. So what DevOps is not actually. So DevOps is not a role. DevOps is not a separate team. DevOps is not combining dev and operations team. DevOps is not a tool. For example, Jenkins, DevOps is not automation, and DevOps is not one size fits all strategy. So DevOps is not what you think it is. So when someone tells you I'm a DevOps engineer, it's not actually that, because actually DevOps is not a personality. DevOps is a culture. DevOps is a way of life. So it's just like saying um, um, Christianity is a person, okay, or Islam is a person. It's actually a way of life. It's not a person. It's not an individual. Okay, so let's see what DevOps is exactly. Next slide. Okay, so DevOps, according to Jez Humble, is a cross-disciplinary community of practice dedicated to the study of building, evolving, and operating rapidly changing resilient systems at scale. So this is by the author of the book Continuous Delivery. So what he's just trying to say here is a discipline that has to do with a mindset of understanding how to build systems that change rapidly and delivering at speed. That's basically what this is. So there's another definition for DevOps too. Yeah. So DevOps is a culture shift or a movement that encourages great communication and collaboration to foster building better quality software more quickly, more reliability. So basically, if you check DevOps too, you're going to hear that it's a combination of development and operations, basically. But if the culture shift is not there, of thinking that the responsibility of system availability, reliability, redundancy, and scalability, it's a holistic responsibility, then the shift of DevOps is not there actually. So there's another definition for DevOps too that we have. Okay, so DevOps is the practice of operations and development engineers participating together in the entire service life cycle, from design through development to production support. So this is exactly what I was trying to say. So it's a holistic responsibility. So DevOps is not a developer's responsibility, neither is it an operations person's responsibility. It is everybody's responsibility. It's a culture shift, it's a mindset shift, and it's a practice that everyone has to be involved in, from the ideation stage to the production stage. And even in production, it's also the responsibility of everyone to keep an eye on what's going on and report cases when they happen, and so on and so forth. So that's basically what DevOps is about. Okay, moving on. So in summary, DevOps is a combination of people, process, and technology. So because it is not a role, it's not an individual, it's not a group of people, it is what? A group of people having a specific process and using technology to drive that process into work. So this brings a lot of things into view. That's where you hear things like continuous integration and continuous delivery. That's where you hear things like infrastructure as code. That's where you hear things like continuous monitoring. That's where you hear things like continuous learning. These are all processes, and these processes need people to put them in place, and you need the technology to drive them. So when you talk about the technology, you talk about Jenkins and all that. We're going to get into that moving forward. So this was what DevOps is on basic terms, actually. Okay, so how do we implement DevOps? Next slide. So there are three ways of implementing DevOps. So we have the first way, the second way, and the third way. So the principle of flow, the principle of feedback, and then the principle of continuous learning and experimentation. Okay, so the principle of flow, what does it talk about? So tools to the rescue. I mean, DevOps to implement DevOps, you need the tools. There are lots of tools that are involved in implementation of DevOps. This is just a summary of some of the tools, and you can see the infinite loop of plan, code, build, test, and release, deploy, operate, monitor, and then it continues in that way. So it's a continuous loop that made up of different tools across board. So if you look at this, you're going to see Ansible, you see Puppet, you see Maven, you see Gradle, you see Jenkins, you see JUnit, and you see Selenium. So all these tools put together are the things that help to drive the DevOps culture using the tools. So I said DevOps is people, process, and technology. So this is the technology part. These are the tools that help you to drive the DevOps culture that you want to drive in your organization. Okay, moving on. All right, so this is just, looks like a huge mess of tools, I mean, but the truth is the tools you use are very, very, they are quite similar, but it depends on your organization, it depends on your culture, it depends on what you're trying to portray and push. So in the AWS world, tools like code commits for your Git, tools like code pipeline for your pipelining, tools like code deploy for deployment of different kind of strategies are the tools that come in handy in helping you deliver and build and test applications faster using the tools that AWS provides for you. So these are more of open source tools, but the AWS tools here that can fit in here is code commit for version control, which is under VCS and for Git. For your CI, code build is for building, testing, and all the other things that has to do with continuous integration operations. And for deployment, you have your code deploy for deployment of different kind of strategies, whether it's rolling deployment or blue-green deployment you want to do. And then you have code pipeline, which covers across board for all operations that has to do with pipelining of code, from build to test and to all, and then to eventual deployment of your code. Okay. Okay, so metrics is everything in DevOps. So because of the way DevOps is very, very volatile and it's hard for people to catch what it is, one of the ways for you to catch DevOps in an organization is actually the metrics. So how do you measure and understand that you started employing DevOps culture in your business and you want to know how it has affected your business? What are the things you check? So these are the 4 basic metrics you check. So there are about 9 of them, but these are the 4 that come out paramount. So one of them is lead time for changes. What lead time for changes? Lead time for change has to do with measuring how much time it takes for a code that is pushed by a developer down to the production environment. So it looks at how long does it take for your build to occur, how long does it take for your deployment to occur, how long does it take for your test to occur, how long it takes for you to release a particular feature or a particular change into production. The next thing you have here is called mean time to recover. So mean time to recover is talking about how much time does it take for you for your system to recover. The previous speaker was talking about always being uptime. Now, the measurement for that is actually your mean time to recover. Now, there's no system that is built that can always be 100% uptime. So even the AWS services, they tell you 99.99, they tell you 99.95, meaning that they usually have downtimes. But the difference between systems is how quickly you are able to recover, how quickly you are able to come back online without your customers knowing or understanding something has happened. So measuring your time of recovery is very important in DevOps. And then release frequency. How frequently do you release changes? Okay. The difference between lead time and release frequency is that lead time measures from push to deployment. Okay. But release frequency talks about release management. So if you have a lot of artifacts in your deployment, how often do you release changes? How quickly can you change? So if you release a new feature and there is a failure, how quickly can you revert to an old artifact that works better than the new release that you've made, and ensure that you release an artifact or a deployment or a change that is working and stable? That's release frequency. And then change failure rate. It talks about the failures that occur in your system. How frequently do they occur? Do you do a lot of what we call shift left in terms of doing code reviews, doing proper, using clean code principles to ensure that you reduce the failure rate of your push? Because if there's a lot of failure rates, your lead time for change is going to increase. Your mean time to recover to will be very high, making your system not actually DevOps, because DevOps talks about speed, agility, and a way to make sure that you are able to deliver quickly and fast in a fast-paced environment. Okay, so that's all from me. Thank you very much.
All right, so this is gonna end. Thank you, Ewere. This is very good presentation, and everybody, the presenter. Thank you, guys. So this is gonna be the end of our presentation. Did anybody has question, so we can all answer? So I'm gonna have we have a question here. It says, are we going to have a deep dive into some AWS services in the future? Yes, we will. This is just an overview, just to get people who are just getting to AWS, trying to understand what, how AWS fit in the world of, businesses and case scenario and DevOps. So yes, we're going to be doing a lot of presentation, and we're also going to circle around to see what people want us to really focus on, so that we know we giving the best presentation to the members. So that's the question. I don't know if somebody has also have any questions. They said, are we having a recording section? Yes, this is recorded. Everybody will share this to everyone soon. Is there any edge servers for AWS in Africa or Nigeria? Yes, there is. Actually, there's one getting built up in South Africa for AWS that I know of. It's still in development stage, but there's none in Nigeria. There's no AWS in Nigeria, but there's one coming up in South Africa. How do we get access? Yes, you're gonna get access to the recording. We're gonna share it due to the distance. Yeah, so that's about it. So we're gonna close this presentation. I mean, I can hold on another 3 minutes if anybody has any question. We're gonna share this to everyone. Okay, so you have the presentation and also the recording. So yeah, so I'm gonna close this. Thank you, everyone. Thanks for the presenters. Thank you very much for spending out of your busy time to present. And thanks everyone for joining as well. Thank you so much. Yeah, all our contacts is gonna be in the slide, so everybody to see it. So yeah, so we're gonna end the meeting. Thank you, everyone. Thank you so much. I'm gonna stop the recording now. Thank you.